Okay. Yeah. So we'll address any questions you have. We'll also talk about class members, methods. Like a wall clock. What do those got? And then we'll talk sort of in general about exceptions and how they're used. And then we'll do a bank and bank account activity. So yeah. So what was the what was the question?
Well, I don't know if this is super useful uh, for the rest of the class because I'm still working on assignment 3 and I still don't actually know what's wrong. Um, this could very reasonably be just a waste of your time, and I'm just not seeing it right.
Well, you're the only one here, so we might as well dive into it.
Okay, so I don't know if you remember what the problem I was having last time, but it works for the the temperature data in all the ways that I can see, except that it doesn't print the last unique line. Um, so it prints all the correct inputs with all their correct tallies until the very last one, which it just doesn't include.
Right. So you exit the loop, and then so is it a is it a while loop or a do while loop?
It's a while loop.
Okay. So the moment it becomes false, um, have you processed the previous line yet?
I would think so.
Do you print out the current line before you make it the previous line? Or when do you decide whether or not it's a duplicate and keep counting?
So inside the while loop, I assign a variable. So while input has next line, string line equals input.next line, and
So
then
I guess what's happening is that you have something like oh actually you have an issue where if the last line is unique that you don't get it.
that would make sense, yes.
Yeah. So
But
what's
that's not what's happening.
that's not what's happening. So if you were to make another file where the last line wasn't unique,
It isn't unique.
okay. Oh,
It's,
so it's a duplicate.
yes, there are 7 of them.
Okay. So and if you made just your own file, like if you just made, this, that, 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 and that was it, like that was the file that you made, do you have the same behavior
I don't know.
where you don't? Well, try it out. That's the trick is that if you can find the smallest data set, if you can create your own data set that's as small as possible that has that same broken behavior, then it makes it much easier to test than having to deal with the whole printout, because here you could easily put in a ton of print statements that prints out each iteration in the loop to tell you what's going on,
Hmm.
as opposed to having to print out the whole weather data set where that's going to be a lot of data being printed to the screen, as opposed to something that's much more simplified that um, still has the same problem, but you're able to inspect it easier.
Hmm. Okay.
So how about that? Try this as input right here.
All right. I'll try that and see what happens. And then I guess I'll come back when I have more questions.
Yeah, so just in general, good testing strategy for anything is trying to find the smallest data set or try to find elements of a data set to break or to make your code work, and sort of expand from it from there. Okie dokie. All right, so wall clocks. So it's really important to just be able to like look at something or just a class of those things and be able to figure out, what kind of private things might that thing have, and what kind of methods or what kind of ways of interacting with that thing might we have. And you should be able just to look at things around in your environment and do this activity sort of in your head. So like I just looked up and I see a wall clock. So what do you imagine the private parts of a wall clock might be? Like what kind of variables might it have?
Well, I'm sure it has time.
Yeah, maybe it has. Yeah, has time. It has its hours and its minutes. What kind of attributes when you look at the clock, like a clock face? What kind of different ways can we display time?
Analog or digital?
Yeah, maybe you have an analog or digital, and if it's digital, maybe it's like a 24-hour versus a 12-hour display. Those might all be private parts that clock might have. Depending on what this class is being used for, you might need to store some private attribute of how much drift do you see over time. That there's quartz crystals for like a computer or for like a smartwatch that those are perfectly fine to lose 3 seconds over the course of a day. But if you're talking about something that's like an atomic clock, or something, or a clock where it's not able to constantly update all the time, then you have to have something that's much more precise. And so when you're manufacturing a clock, those tolerances are known, and so maybe that's one of the attributes that you have. Um, if you have a smartwatch and it's offline, you're going to notice it drifting a lot. Versus a dedicated wall clock has much that's never expected to be connected to the online to be able to calibrate its time. It has much more accurate time just by itself. So that might be a private thing that you might store, things like that. And then what kind of methods? How do you interact with the clock?
Well, you would need to get what time it is.
Yeah, need to read the time. And then what else? When it's brand new, what is the first thing you have to do?
Construct it.
Yeah, and what do you when you construct it? What do you typically do?
You set values for some of its private parts.
Right. And so what was one of those private parts that you might be the most important thing to set for a clock?
Probably time.
Yeah, exactly. Time. So being able to having getters to be able to get what time it is, and setters to be able to set the time, and that's that's pretty much it. Depending on what kind of clock, if it's an alarm clock, then you have more things that you have to set and get. Um, and then maybe it has internal methods that it calls or they get checked, like should the alarm be going on off right now. um, some state machines like a real alarm clock, what they do is that they have a method that says, should I be playing the alarm sound right now, and it's just in a loop that just keeps calling that repeatedly, um, and then it waits for a button press event, and then it will delay the time, or it will stop, or it'll set a flag that says stop the alarm. Yeah, so things like that. Um, and I encourage you to like look around in your day-to-day life and think about generalized things, and what things make those things connected. And sometimes even just picking two objects at random, that maybe you don't think of any association with them. Like you pick a cup and a shoe, you say, okay, well, what things do they have similarities to? And it may just be the fact that they are in the same environment together, they're in the same room together, and their spatial location is one of those attributes, one of their private attributes. And maybe the way that you interact with them is that you pick them up, or you move them, or you clean them, or whatever. So just a good mental exercise to help flex your brain muscle. Okay, so exceptions. What were some of the examples of exceptions that Jeff showed off in class and that we've seen so far?
There was like inputting the wrong type of, or giving the wrong type of input.
Right.
String when it wants an int.
Right. Yeah, we saw that. We saw it with the right. So like if I try to pass the integer class a string instead of a number, right? A number, it's perfectly fine with it. But if I try to feed it in a string meh, it's gonna barf. What else?
I don't know if they're technically exceptions or if they're just errors, but things like division by 0 or negative indices.
Yeah, so if I try to divide by 0, it's an exception, arithmetic exception, divide by 0. And then, negative indices. So that's like an array.
Yeah.
Yeah, so if I try to make an array, let's just make, so let's just make an array. And then if I say I array, and I try to go to, -1 and set it to 2, right?
I guess that's any out of bounds.
Yeah, exactly, any out of bounds. So if I was to say, let's set 12 to, the index 12 to 5. Oh, whoops, I missed the I array. There we go. Yeah. So out of bounds. And essentially anytime, so essentially anytime that we're trying to do something and we shouldn't be doing something, or that we don't have access to doing something. So yeah, so array indexes, maybe a file doesn't exist. So let's just try to go to this file. Well, okay, so we threw an exception and we see no such file exception. So let's go and create that file. So now that file exists. Let's try it again, and there we go. It's all good. We were able to open the file. Now, if I interact with input file just like the normal scanner, I'm able to do that. But let's change the permissions. So I'm essentially making it so that nobody has permissions to this file. So the file exists, I just can't read it. And I can't write to it and whatnot. Oops. Let's see. I don't trust myself to type things in, so I just copy pasta. And so then see, we get a different exception. We get this access denied. So what happened before was when there was no such file, we got a no such file exception. When I created the file, we didn't get any exception when the file existed and we had permissions to read it. And then here, where I removed permissions, it says access denied. So those kinds of things. So exceptions are really, really useful for letting us know that something's done wrong. And in the lecture today that Jeff will show off, you can actually catch those exceptions. And so what's useful is that while you're doing an operation, maybe that you took user input or something like that, you can catch those exceptions and then sort of handle them in a way that makes sense. Maybe you ask the user, hey, invalid password, try it again. Or a file doesn't exist, did you mean this? Or any things along those lines, as opposed to other languages that don't have exception handling. You have to be a lot more clever in trying to prevent the system from taking down the whole system. Exceptions allow us to contextualize how something broke and then to be able to specifically handle how that broke. And in some cases, you may not even want to recover in a way that the program continues running. Maybe you throw an exception and there's no possible way to keep going, but you want to still catch the exception to close all the files and to sort of clean up your environment. Maybe even just printing out to the user, goodbye, or database file is corrupted, goodbye, as opposed to just throwing a stack trace and overwhelming the user. So handling exceptions is really important, and Jeff will be showing us how to do that momentarily. But yeah, they're very nice because they also tell us when we're debugging code, they tell us where something bad occurred, and the stack trace does, and it will give us some information about what's wrong, like index out of bounds or file doesn't exist or things like that, as opposed to a lot of other languages where they just crash and you have no idea why they crashed, and you sort of have to open them up into a debugger if you have one for it, and that takes a lot of work, as opposed to Java is very upfront about why something happened. And that's because what's happening is that the Java VM, the virtual machine that we run our code in, it actually is catching all of those exceptions itself before it closes up. And so it's catching the errors, so it knows what they are. And we can sort of do that instead of allowing the VM to get those exceptions. Ultimately, once we're done with this class, we should pretty much never throw an exception that we don't then catch ourselves. But for the time being, right now, we're just passing the buck. If something breaks, we're just giving it to the VM at the virtual machine, the Java virtual machine, and it's printing out the stack trace for us. Okie dokie. So let's see. Yeah, we got.
I'm sorry, I actually have to go.
Oh, okay. Well, thanks for stopping by.
Yeah, thank you.
Yep.
Goodbye.
Yep. Okay, so let's do bank activity. So we have two classes here. We have our bank account and we have our bank. The idea being is that a single bank has multiple bank accounts. And in this case, we don't know how to make variable arrays that are able to change sizes yet. We haven't been shown that. So we'll just make a bank that holds some humble amount of accounts, and that there's a default constructor for that bank. So it essentially just sets the number of open accounts to 0, and that the bank has really only two methods: the open bank account and then let me turn on the pointer, and then the get bank account. And when you open the bank account, that's just that might return some data. That's really up to you, right? When you make a bank account, typically when you walk into a bank and make a bank account, they hand you a little membership card with some kind of account number or something like that. That way that you can reference to your own bank account. So maybe we have open bank account returns a bank account number, and then get bank account maybe goes and accesses that spot in the array of bank accounts and then returns that element, or returns that item. Because then maybe this is, maybe get bank account is used by an ATM. You put in the card, then the card goes through and finds the matching account number, or you walk in and give it a bank account number. But the thing is that the index in the array has nothing to do with your bank account. When you go and open a bank account, you have no idea how many bank accounts there are. You have no idea where they started counting from, and such. Yeah, so let's just make a bank account. Oops. Sorry about that. Let's see. So I want to do, we're going to call this bank. Hopefully my typing isn't too loud. So let's make our methods. And so the bank account number is going to be an integer. Oh, and let's check main. We don't need a main for now. We also need a scanner. So we need a constructor. And so if we recall, constructors are just the name of the class. And then for open bank account, we're gonna give back the account number. And then maybe get bank account, we're going to return something of type bank account. So right now I'm just making all the skeletons. And get bank account, we're going to need some input, and that's just going to be the bank account number, right? So just account number. So right now I'm just making a base skeleton of the class, and then we're going to jump over and make the bank account class. So we're going to have, we need the array of bank accounts. And then maybe we need to know, just like a partially filled array, we need to know how many bank accounts we've actually opened, because we're a bank, and that's sort of important information. So maybe the first private part that we're going to have is going to be open accounts. Maybe let's just set that to 10. We're a small bank, we're just starting out. And the reason why we want to make these private is that we don't want some outside entity to be able to reach it who's using our bank account or our bank, and reaching in and changing these things. Oh, actually, whoops, sorry. That's not open accounts. That would be capacity of accounts. So this would be, I just realized I'm mixing camel cases. And okay. So the number of open accounts actually when we start off is 0, but the capacity, the number of accounts that we can have is 10, because we're a small bank. Okay, so we're going to make of type bank account. It's an array, and we're going to call it accounts new bank account. And this is where we use this private. The idea being is that if I needed to change, if the bank needed to scale up and have more accounts, we would just change this one number, as opposed to having to type 10 everywhere. That makes it much more difficult for us to change our code, because we would have to go everywhere, because maybe there would be a 10, maybe there would be 9 somewhere, whatever. Maybe instead we could just say cap accounts -1 if we needed some reference between 0 and 9, because those would be the indexes of our array. Okay, and so then maybe here in the constructor, oops. Okay. All right. Greetings. Greetings. We're making bank accounts. So as the default constructor, we would, we're going to just make sure that we reset the number of open accounts to 0. And that being that this line here, we don't have to depend on this part happening. And it's always good that if somebody recalls the default constructor, that we just set it to 0 just in case. But also any kind of setup that we might want to do. For example, if we wanted to make all of those bank accounts and store them with a certain amount, maybe to open a bank account, there's a certain cost that's associated with opening the account, and that gets deposited into the account. I know a lot of banks, they'll say, like, in order to open an account, you have to have $5. So you could just defaultly here set the value, go in to all of the accounts, create all of those accounts in advance. Maybe there's not a name associated with them, but there's an account number, and that there's a default balance that they all have. You would do that here. But in this case, we're just gonna set the number of open accounts to 0, and then that's it. Okay, so now let's write get bank account. So this, all we're doing is just like the 2 weeks ago when we were making partially filled arrays, we're just going to essentially use this partially filled array. So we're going to have a for loop that iterates through accounts. We're going to start it at 0. And so we want to use open accounts as what we're iterating through, right? Because we don't want to iterate through parts of the array that aren't holding valid accounts in this case. And so what we're going to do is we're going to say, hey, if the account number and notice in this case, we might have to throw an exception here, or what do we do? What do we do if there's no bank account that exists? We could create one and then just return it. But in this case, we're just going to assume that everything is all kosher and that the bank account exists. So get let's just say account num, right? Or was that what we called it? Get balance. Yeah, we're just going to call it that. And then we're going to check. So this is an integer. So we're going to check to see if that integer is the same as this integer. And then right here, we're going to return that particular account. Oops. And so if we found the account, so yeah, so let's just go through this again. So here's the method here. So it's going to give back something of type bank account. It's called get bank account, and it takes in the argument of a bank account number. Then we have a for loop that's going to iterate through all of the open accounts, not the whole array, because maybe there's only one account that's open and we don't want to iterate through the whole thing. If we're a really large bank, we don't want to have to go through the whole thing. So only through the open accounts. And then if the account number of the thing, one of the iterations that we're going through of that for loop, if its account number is the same as the account number that was passed in that we're looking for, then we're going to give it back. Then we return that bank account. And then we just keep going until we find it. And we're going to assume that so here we'll just make a generic bank account and call it good if it wasn't found. So if somebody was searching for a bank account, it didn't exist, we're just going to really quickly create one, but we're not even going to bother to store it in the bank. This is a case where we should or actually, oops, this is inside the for loop. We need to be outside the for loop. So here we should throw so right now we're not going to throw any exceptions, and then here, but we should, because in this case, if we're right here, then that means that we've gone through the whole thing and we haven't found that bank account, and we have no nice way of informing somebody besides an exception that that bank account didn't exist. And we could return an exception that already exists in the Java language, like no element found or something like that. But for now, we're just going to return this bank account. And then, so that's get bank account. And then let's write the other one, open bank account. And so this, all we're going to do is we're going to stuff into the array at a particular spot. Oops. So we might check to make sure that we are not full. And let's say that if we are full, we're going to return some negative number. And this, we might also throw an exception. And so how do we know that we're full? Well, we're going to look at open accounts and capacity. If these are equal, then that's a pretty good indication that we're full. And actually, this is going to be the index. So when this is 9, so we need to say open accounts, and we might say +1 or something like that. Because the capacity, because this is the number of accounts, but this is the if we make one, let me double check this. So if we make an account, then this becomes 1. Right. So this is always going to be off 1 by this, because this is the capacity, the number of elements in the array, versus the number of versus the indices of the array is 0 through 9. So let's just double check that. And let's make sure that we're using this right. Yes, as long as this is smaller than open accounts. Oh no, actually we're good. So we don't actually need this +1. But that's something really important to think about though. Because this is pretty common. And so here we're just going to return -1 for now, with the understanding that you might throw in exceptions that makes sense. And you could create your own exception, or you could use one that's just off the shelf that already exists in the Java language. Okay, so let's actually open the bank account. And so essentially we know already that whatever this spot is, open accounts, that index in the array doesn't have anything yet. So when it's empty, right, when there's no bank accounts that exist, it's 0, which happens to be the index that we should probably put that bank account in. And so we do a post increment. That way, when we're done with this line, we're going to increment open accounts. So open accounts will be now 1, telling us that we have 1 valid account. And that happens to also be the index for the next spot in the array that we would put a bank account if we needed to put one there. So we're using open accounts for 2 purposes: to keep track of the index that we're going to put the next bank account in, and then also to tell us how many bank accounts we have. And so we might also, at this point, collect user input when we go to make it. So we might say, cool. Okay, well, it's time to jump over to Jeff's class. So I'm gonna save this bad boy, and then I'll post it. I'll post it online. Good stuff.